You know, out in our gardens and farms, there's a silent war going on, a war that most of us never even see. It's a battle between our honeybees, which are so vital, and these invasive hornets that can literally wipe out an entire colony. But now, a new ally has joined the fight, one that can see the enemy in a way that we never could. So here's the roadmap for our explainer. First, we'll dig into the silent insect crisis itself. Then we'll see how you can actually teach an AI to see these tiny targets. We're going to check its accuracy, explore that big leap from just detecting to actually defending, and then see how you can mess around with this tech at home. And finally, we'll dream a little about the future of all this. All right, let's dive in. So, what's the big problem we're actually trying to solve here? Well, it's so much bigger than just a few wasps ruining your picnic. We are facing a massive global decline in insect populations, and that has huge consequences for our ecosystems and, for our food supply. And look, this isn't just a feeling people have. Researchers are sounding the alarm. The decline is so serious that it's created this worldwide demand for better data. It's simple, right? We can't protect what we can't measure. And right now, our measurements are just not cutting it. So why is this so ridiculously hard? I mean, think about it. Tracking a bear or a deer is one thing. But insects? They're tiny, they are mind-bogglingly diverse, and they are absolute masters of disguise, blending into leaves and flowers. Trying to track them the old-fashioned way at scale, it's pretty much impossible. To really bring this home, let's zero in on one specific villain, the invasive Asian hornet. In South Korea alone, this one predator is causing damages worth about 170 billion won. That's over 120 million US dollars. And that's not a one-time thing. That's every single year. It is a full-blown economic and ecological disaster. Okay, so if humans can't possibly keep watch 24/7, what can? Well, this is where we get to the really cool high-tech solution. We train an artificial intelligence to do the job for us. We're essentially creating a new kind of digital entomologist, one that never gets tired and never sleeps. And the engine behind all this is a brilliantly named algorithm called YOLO. It stands for You Only Look Once. Here's the best way to think about it. Instead of scanning a room slowly, piece by piece, you just glance at it and you instantly know, okay, chair there, table there, lamp over there. YOLO does the exact same thing with an image. It just looks once and finds everything, which makes it incredibly fast. But for an AI to get smart, it needs a really, really good textbook. And creating this one took a massive team effort. First, they used a basic AI to sift through millions of images and say, hey, I think this might be an insect. Then, a whole army of citizen scientists helped screen those suggestions. And finally, real entomology experts did the final quality check, creating this perfect gold standard dataset for training. And the result of all that incredible work? A final dataset with just shy of 30,000 perfectly, expertly labeled insects. You have to understand, in machine learning, data isn't just important, data is everything. And this huge amount of high-quality information is what gives the AI its superpower. So we have the problem, and we've built the high-tech solution. But the real question is, how well does this thing actually work out in the wild? Let's take a look at the results because they are stunning. The performance is just remarkable. You're seeing nearly 93% precision and almost 94% recall. Let's break that down. It means when the AI says, hey, that's a hornet, it's right almost every single time, and it almost never misses one that flies by. For spotting tiny, fast-moving targets against a messy background, numbers like these are absolutely incredible. Okay, so it's a total rock star at identifying the insects it's studied for. But what about a pop quiz? What happens when a totally new species, something it's never seen before, flies in front of the camera? Does it just ignore it? This is where it gets really fascinating. The model actually spotted 80% of insects that were completely new to it. Now, it might get the label wrong. It might see a rare type of wasp and just call it a yellow jacket, for example. But the crucial part is it still sees it. It recognizes the unknown. And that means it can be used to flag new, potentially invasive species for experts to look at. It's a huge deal. So look, seeing the enemy is critical, but it's really only half the battle. Right? Now that we can spot these hornets with such amazing accuracy, how do we make that jump from just passively watching them to actively defending the bees? You can really think of this as two different game plans running at the same time. On one side, you've got the AI detection approach we've been talking about, which is mostly in the world of research right now. And on the other side, you've got active defense systems, things like physical repellents and traps, which are already being turned into commercial products. And speaking of repellents, check this out. A really cool South Korean patent has revealed a new path forward. It's a repellent based on a simple chemical compound, and it does something truly remarkable. It keeps hornets away, it actually chills them out, and suppresses their aggression. And, this is the most important part, it's been tested and confirmed to be totally harmless to honeybees. And hey, while we're talking about defense, here's a quick pro tip you can use yourself. Science shows that wasps and hornets get extra aggressive towards dark colors, like black and brown. Why? Because those colors resemble their natural predators, like bears and badgers. So next time you're outdoors, maybe skip the dark shirt and wear something bright. It could actually make you a less interesting target. You know, this kind of advanced technology used to be locked away in university labs. Not anymore. It's becoming so accessible that you can literally start experimenting with it in your own backyard or your garage. Seriously, platforms like Edge Impulse have made this whole process shockingly simple. You can use your phone to snap pictures of whatever you want to detect. You go to their website and just draw little boxes around your objects. You click one button and their powerful computers in the cloud train the model for you. And then you can download a file that's ready to run on a tiny, cheap computer. It's amazing. And the hardware for this is getting cheaper and more powerful every day. On the DIY end, you can grab something like an ESP32-CAM for about $15, which is perfect for hobby projects. But if you want more power, for just a bit more money, maybe $30 or so, you can get a professional board like this Grove Vision AI. It gives you much faster, smoother results and uses less power, making it perfect for a more serious project. So finally, let's just zoom all the way back out. We've got an AI that can see, and we've got repellents that can defend. So what happens when we start putting all of these pieces together? And this isn't just some sci-fi fantasy. This stuff is already hitting the market. A South Korean company called BioBee has taken that bee-safe repellent technology and turned it into a real product called 말벌가라, which pretty much means hornet go away. It's giving beekeepers a brand new tool to protect their hives today. Which, of course, leads to the final awesome question. The pieces are all on the table now, aren't they? We have an AI eye that can spot the threat from a distance. And we have a targeted defense that won't cause any collateral damage to the bees. The next logical step is to connect them. Just imagine a smart beehive that sees a hornet approaching and automatically deploys a tiny puff of that bee-safe repellent, an automated guardian for the entire colony. That future might be a lot closer than any of us think.